We are able to turn a list of numbers into a number, but it turns out we can produce more than just that. Let's turn a list of numbers into an image, specifically a stack of circles of different sizes on top of a triangle. We're reusing our list data definition, so we can once again jump straight to the function definition. We'll call this function stack circles, and it consumes a list of numbers, produces an image. Consumes a list of numbers, and produces circles of the given sizes, stacked on top of each other. The bottommost shape, just to mix things up, will be a triangle. That triangle will always have the same size. We define the header, stack circles, consumes a list of numbers, and we'll leave a dot 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 for the body. The check expect for empty list is going to be pretty straightforward. We say that it stacks circles on the empty list, and that produces our triangle at the bottom, and we'll make it a solid black triangle of size 10. Easy. Unfortunately, for our check expect of the 4-element list, it's going to be a little bit more verbose. So there's not really a good way around it. You just sort of have to write it out. So we'll say that we have the above circle 1, since the first element was a circle of size, a number of size 1, and that is above the result of putting a circle size size 6, that is solid blue, above the result of calling circle on 3, solid blue, above a circle size 5, solid blue. Probably going to make a typo doing all this. And then finally, all of this rests on a triangle, once again, that is solid black. No real way around it. When you're testing images, you often end up with these nasty check expects that look kind of like this. Sometimes it's the way of the world. So one advantage of looking at this, though, is that we can build the expected output here and get a clue about what Dr. Racket is going to do on our behalf. By recursively combining these above and circle calls, we'll end up generating the stacked circles. However, that is hidden by our function definition. Let's put in our template and see for ourselves. Because we have a list itemization, we end up with two clauses. First one finds out, is this an empty list? If it is, we'll do something. Otherwise, we ask if it's a cons list, in which case we'll do something else. That something else is going to require the first of the list in some way. It's also going to require the stack circles operation on the rest of the list. Now, we still don't know how we're combining the first and the stack circles of the rest. But at this point, we've got our template in place. In the empty case, we said that we're going to create just a simple black triangle. We'll make it size 10, solid black. In the recursive case, we have two tasks. First, we need to create the circle using the current item. Then, let's do the circle first, actually. We need the first element of the list, which is a number. That makes the size, and then it needs to be solid blue. Next, we need to use the above function to combine this circle with the result of calling the stack circles function on the rest of the list. So we have above, and we need to pass in both the circle and the stack circles. If we fix our formatting, we can see that we're off by one parenthesis, so we'll finish that up. And our check expect should now hopefully confirm that our function produced the right result. All right, all tests passed. But let's take a look for ourselves. We have stack circles, and let's make a list of size 3 with the numbers 10, 30, 20, and then empty at the end. And that produces a lovely little image.